Hangout is now live. Hey everybody, welcome back for another video. Today we are in a live event, obviously. Hopefully you've joined us from either YouTube, the notifications, maybe through Twitter or Facebook. Today we are going to go over how to troubleshoot HVAC, how to troubleshoot electrical, and this skill set that we're going to talk to you about today can be used across a wide variety of things, and hopefully we can get you some information that'll help you learn how to troubleshoot almost anything. So let's get into it. Joe's joined us, and he's on the other line here.
Hey everybody, how you doing?
You know what, Joe? And again, this is our we're still in the beginning stages of learning our system here, and last time we were toggling okay, and this time we're not, so I'm not sure what's going on there. So I might have to manually toggle us back and forth, Joe.
Okay.
Joe is monitoring the comments section below. There might be a little bit of a delay. I am going to...
You got mail.
I got mail. I'm going to be monitoring my Twitter. So if you want to see the Twitter account, you can go down below into the comment sections, and there'll be a link to the Twitter there that you can go ahead and follow, and then leave some comments down there, and I'll try to follow those along. Okay, now that we got this up and running here, basically let's start with my expertise in my field here, and that's HVAC. So this is a real big problem a lot of times with beginners, newbies, even people that's been working on this stuff for a while. Troubleshooting seems to be the area that they have problem with, especially when it comes into the electrical side of things. And this is where not unless you work for a manufacturer, like, you know, a large manufacturer like say Trane or Carrier or something like that, you work on every type of piece of equipment that's out there. So when you're working on this much type of equipment, and you're talking even different styles of systems, you know, boilers and air conditioners and geothermal and water cooled and air cooled, and, you know, just all sorts of different types of stuff. There's absolutely no way you have it all upstairs 100%. What you have to do is learn how to run through the process, learn how to troubleshoot, diagnose the problem, and store each service call and each issue back there in the memory bank so you can pull that up later, and help you through maybe another similar issue that you may run across. But so when it comes to troubleshooting HVAC equipment, and pretty much anything, is you need to know what that piece of equipment is supposed to be doing. That is the biggest key right there. Know the sequence of operation. You've been doing it long enough, you can just look, watch, and observe a piece of equipment, and at some point that fail is going to show itself. And if you know the sequence of operation, step A, B, C, D, E, and then it stopped at E, but it didn't go on from there, then you know that the rest of everything behind that, you don't even have to bother looking at. You just need to look at this and on forward. That will save you a lot of time and headache when you're out there in the job. In some cases, and I recommend that everybody, especially if you're new at this, start at the beginning. And starting at the beginning is, do you have power? And if you've got power, then you can get into the piece of equipment. If you don't, then you got to go back the other direction. And Joe's going to highlight on that side of things here in just a minute. So knowing the sequence of operation, and this is going to get you through knowing where your problem is going to be. Joe, go ahead and talk a little bit about the electrical side of things and what, you know, any tips you got for that.
All right. Well, the electrical side of everything is pretty simple for the most part. Power is obviously coming to your piece of equipment from a distribution center. So either a panel or a some kind of a uh, breaker box. You have disconnects, wherever it's coming from. Regardless, the as the as the power comes into your unit or module or your machine or whatever you're working on at the moment, um, that has to do a lot with the understanding, like I was saying, understanding the process of how things work. So power comes into this unit, and that has to be verified first and foremost. Um, if that's established, then at that point you can go on to things, say stuff like checking for functionality. If it's operational enough to, say, turn it on, and you actually get a screen or to get a any kind of a life into the machine at all, that's a step farther. Um, as Guy was saying a minute ago, also as well, is to know how the machine works, understand how the machine goes from step to step, and how you can take a any kind of machine and break it down into its functions. So if you work on a machine long enough or a thing, you can understand that it has noises, it has rhythm, it has, you can tell when something's off. When you can walk by a machine and it's making a funny noise or a squeak or a whatever, you understand that something's going on, not normal. So when the thing shuts down, you can bring it up to a certain level and say, okay, this is what it's supposed to be doing, and this is what it's not doing. On the electrical side, which is more of my strength, um, really getting in there, understanding, what is supposed to be powered up. So let's just, use an example of a large piece of equipment, say a piece of machinery. You're probably going to have some kind of drives in there for motor drives. You're probably going to have some kind of a system where you could have a control center, a PLC, that stuff. So first of all, you check your power, you make sure power is coming in. If power is not coming in, there's your problem. At that point there, you verify that you have, say, a three-phase system, you have all three phases. And each part of this, we're going to break down each of these things in detail in further videos. These are, again, these live events are more of overview. But you would, anyways, you would check your systems. You would make sure that you have three-phase power coming in, or at least your power that you are required, 480, 277, whatever is you're bringing into your system. Once that's established, then you go on to the next level. Is your processor powered up? Is your machine powered up? Is your controls powered up? Is it a relay logic machine with actual real hardwired relays? Make sure that you have power into that section. And after you get to that point, it's basically a matter of playing, a version of the mouse game or mousetrap. You take electricity's coming in and it has to go somewhere. It has to go to your motor. If your motor's not running, why? What is not turning on? I've had situations where just a simple, excuse me, motor overload or something would come on or open up from a overcurrent, causing the motor itself to fail. If that's the case where that motor's overloaded, it'll take that piece out. So I'll check there. I'll say, okay, well, do we have power at the bottom of the contactor? Do we have power at the disconnect? Do we have power? So troubleshooting is basically a matter of understanding your machine, or understanding how things work in a large scheme of things, and then breaking it down to its components, breaking down to its smallest parts, and troubleshoot each part. So if you want to do it, you have.
Oh, yeah, there we go. Sorry.
Oh, okay.
Yeah, that was my fault. I had it muted from last time. So, um, back up. So you were talking about motors and thermal overloads. And for those of you who don't know what a thermal overload is, it is where there's a temperature switch that will sense the temperature of the motor. And for an example, if like you said, if the motor's being overloaded, there's too much strain on that motor, it'll start to draw more amps. And when you draw more amps, you produce more heat. You produce more heat, then you could fry out the winding. So it protects itself from overheating and will shut down. But some of the hidden problems now that would be the you've diagnosed that the motor is shutting off on thermal overload, but you have to go deeper. A lot of times you just can't say, oh, well, the motor's bad. Sometimes you have to look a little deeper, and you can never, ever trust that what you're working on is the way it's supposed to be. For example, today I was working on a heat pump where the electricians that wired it up, I had a 70 amp breaker in the panel. I had a 60 amp breaker at the disconnect, and the unit actually called for 90 to 100 amps. So the call was, it keeps tripping off on limit, or it keeps tripping the breaker. I had another service tech tell me that he couldn't figure it out and wanted me to go look at it. And he disconnected the compressor and it still tripped. And he disconnected I don't know, I can't remember what he said. He kept disconnecting things and it would still trip. So I was like, well, Jesus, it kind of sounds like a bad breaker or something like that. But anyway, when I did all my homework and I checked out all the parameters, and I found that it wasn't installed properly. So in a motor case, you might find that maybe somebody put on a too small of a motor and it's been overamping the whole time. Or maybe they changed pulleys and got the wrong one, or maybe there's an air restriction, or you just never know what the problem might be. So never ever take just changing a part at face value. Make sure you dig a little deeper and make sure there's not an underlying problem there, because that's where you are going to shine over everybody else. If you show up to a furnace, for example, and you've got 6 pressure switches laying there, well, geez, I don't know. The problem keeps happening every year. They got to keep putting pressure switches on there. Well, you might want to try to figure out why they keep changing pressure switches. It's probably not that. It's probably something a little deeper. And Joe, real quick, we talked about power coming in. And let's say 208, 230 volt or 120, whatever. Isn't it correct that most pieces of equipment accept whatever voltage plus or minus about 10%, right?
Yes, that's correct. Usually the manufacturer differs on what it can handle. But a rule of thumb is plus or minus 10, and it goes up on heavier duty equipment. Now, typically, you're going to have your power rating is going to be somewhere around. Let's say you have a 480 system. 480 automatically determines that you can have a 3-phase power system coming in. At that point there, you have 3 phases of power. If we just at that point there, let's take that point of 3-phase power coming in. Let's say that we are having problems with a motor. Like you were saying, a motor can have problems with overload, which means it's too small. You said that. You also can have problems with whatever it's attached to mechanically, a gearbox or a blower or whatever hanging up and having problems. That's the second side of it. So physical load is one big thing. Another thing is the fact that the motor maybe has gotten wet, has gotten worn out and old, and the windings have gotten broken down. So the insulation is not as well as it was when it was manufactured. Some other things that can happen is environmental. Just what it's in, the dust, the environment it's in, or, voltage spikes. So things happen to motors all the time, which cause them to or pull too much, one leg or another. This being the case is that, you have to understand that power coming in and how to troubleshoot that. So one thing I always do on my thing, I'll take my meter. I have a fluke meter in my pouch. and I'll check all 3 phases on the load side. Now, for those of you not familiar, you have panels that come in on top as your load, or sorry, your line, and they leave in the bottom as your load. So anything that's driving or being driven is the load side. It's actually the load, the pole. What is provided as line. So you have line and load of any system. You're at your disconnects, your fuses, any of that stuff. So we'll keep in mind, let's say it's a fuse system right now, 3-phase fuse box. First thing I'm going to do, as far as troubleshooting goes, I'm going to check all 3 phases. I'm going to take, we're going to call them A, B, and C. All right. So I'll take my meter, I'll put it on A phase, and I'll touch B. I should have a reading of 480. Then I'll go to C. I should have 480. And then I'll go to B and C. And then I go to B and A. And I'll just do all the different combinations to make sure we have power coming in. At that point, please the ground. And the other one I'll do A, B, and C individually, and C its individual components. So I should see 277, 277, 277, or 208, depends on what the transformer is. In this case, we'll say 277. All right. So once we establish that power is coming in on the line side is correct, at that point, now we got to check our fuses. So at the bottom, we'll do on the load side, the bottom of the fuses, and we'll do the exact same thing. A to B, A to C, B to C, C to A. All the different combinations, all right, to make sure we have 480 coming in on the backside. But that there will trick you. You got to be very careful, because if you're troubleshooting at that point, you can actually get a feedback from the motor. And let me understand or explain how a motor works inside here. So a motor is a winding. A motor is a wire that has left a fuse on the load side, has gone into the armature or the stator of the actual motor itself. It's completed a complete winding and has come back on a different phase. So when you actually are checking 480, 480, 480, get 480, like, I'm good, your motor's bad. Well, in reality, you have a blown fuse. Okay, so and what's going on is you're actually seeing, let's say, B phase come through the winding and back up to C phase. So when you check it, you're seeing 480, but it's not really there. All right, the next thing I do, again, ground, and then A, B, and C. I should see 277, 277, 277. Again, this will lie to you. This is a quick one. So my last thing I do to check, I'll take my on voltage now, not on ohms. So set your meter on voltage and put 1 on line and 1 on load. I should see a value of 0 or something close to it. I'll go to the next one, B. I should see 0. And next one, I should see 0. But if I see anything, if I see 277, that C phase is blown. All right. Now, typically, when a motor is actually has gone, it will take out at least 1 fuse, but usually 2. And the reason this is because once 1 goes, it puts super load on both on the 2. We're called single phasing at this point. Once single phasing has happened, it overloads the system, and one of those up to just roll the dice. And eventually, when you do troubleshoot it, when you do get a call, when you do actually get out there, you're gonna have 2 fuses blown. And that's because of that reason. Once 1 goes, it loads the 2 down as a single phase, and off it goes. If those fuses don't blow, the motor is what's going to take your hit, and that's the worst case scenario, because you're going to destroy your motor. Your motor is at that point, it's going to be fried. It's going to actually turn to a giant heater and destroy itself. So when we get into that point of the troubleshooting, fuses are going to be your first protection. If you have the same thing on a disconnect or a relay or motor starter, you have your heaters, which Guy just explained about the heaters. It is a thermal reactive device that will trigger on high current. High current will build heat and open up a physical switch. Once that switch has been opened, you lose your connectivity in the same thing. So we're going to have the same problem as single phase and a fuse. Excuse me, single phase and a fuse, but it's going to be on the lower part of a contactor. So if we're looking at a motor starter, the top section is a starter, is a relay, and the bottom part is a set of heaters or thermal overloads. Together as a combination, that is your motor starter. So once power comes in, A, B, and C up top, you have a set of contacts which is being closed electromechanically through a coil. So once the coil is energized, it's going to make a magnetic field, which is going to draw these pieces together and pull it through that system. Once it goes through that system, it's going to go through the overloads, and once the overloads are overheated through overcurrent, one of those will blow out. If they're not blown out, it should go right to the motor. The motor will continue on all 3 phases and continue that rotation. And we have a whole in-depth thing on AC motors and how that stuff works. Is coming up very shortly.
And we can expand on that and get into freak drives and things like that, so we get soft starts on the motors. But I did want to touch base back with on the HVAC side of things. There's a device called a mega ohm meter, and you can actually test the windings. Now, Joe was saying that electrical windings can degrade over a period of time. Heat will degrade the coatings on the wires, and you can actually get a loss through the windings. And so you can actually check the current through the windings in a compressor using a mega ohm meter. And it kind of gives you a lifespan of the motor. We can get into more detail on that later, but I just want to let you know that was out there. So yeah, the troubleshooting, you've touched on a lot of great points, Joe, and we just getting into the electrical side of things, which is where most of the people have the problems, and that's why I wanted to touch base on this stuff today. And again, we can get into more detail in future videos. I do want to expand on something else you said, Joe, and that was 277. Okay, now pretty much across the board, when you're dealing with 277, that would be a lighting circuit. And now I don't know how your electrical company puts your electrical together down there, but we have wild legs up here in our region. I'm not sure if you do there or not, but can you just real quick just skim over the top on the Delta systems, Delta Y, and that sort of thing, for everybody to understand, and explain briefly the wild leg?
Yeah, sure. So distribution side is not my strongest point, but I do understand the basics enough to at least explain how this works. So you have two different types of transformers. You have your Delta and your Ys. Each one has its own purpose, I guess. So the Delta is going to be a three-phase system. 3 phases coming in, 3 phases coming out. Typically, it's a step up or step down or isolation transformer. You have 3 different types. Step down transformer is going to bring a power in. It's going to step it down to a lower voltage for you. Step up and be the exact opposite, coming in at low voltage, stepping up to a higher voltage for blowers or something that's going to take a lot of current. And your isolation is just that. It isolates the line side, the power coming in from the load side. Sometimes this is required on a lot of machinery that causes a lot of noise. Noise being things that are anything that has a lot of inductive materials, contactors, motors, starters, all that stuff cause a lot of noise and chatter on the electrical lines. This is sometimes required in some cities to have an isolation transformer in order to isolate the 2 sides. Plus, any kind of spike or anything happens on the outside will not affect the inside. So that is pretty much the Delta in a layman's term, close as I can get without getting real detailed into how this works. The Y transformers are used for adding a neutral. So where your Delta comes in and it just 3-phase comes in, 3-phase for large industrial settings. Y transformer is going to be more for residential, commercial, that kind of setups, like apartment buildings or if you have like an office building. Power comes in as 3-phase and will leave as either a single phase or 3-phase, depends on the setup, but usually a single phase with a neutral. You can also have a 3-phase with a neutral as well on a Y, but it's there's different configurations as they go. Now the high leg you're talking about, or wild leg you called it, its purpose is for one of the phases on the panel. So you have a 3-phase panel, A, B, and C. We'll say that B phase is the wild phase or the high leg. Purpose of that is for large HVAC equipment or large motor loads on a commercial building. So where your copiers and your computers and stuff are going to be on your A and B phase, providing a single phase power. If you take, let's say you have a 3-phase panel coming in, 277 per leg, or with 120 you have. You can take any phase, so let's say a C phase to a neutral, and you have 120. Or you can have from A to B phase and have a 208. But if you access that middle, A to C phase, if you access the B phase, which is your high leg, that is going to be your wad leg, your high leg, whatever you want to refer to it as. And that is simply for high loads, because it is a higher voltage, and it is for things that are going to draw a lot of current: blowers, motors, pumps, things that are that's required for a office building, but you don't need that high voltage on all three legs. And again, it just for that one purpose. The problem comes with those high legs. If you're not careful, or the electricians are not careful hooking it up, you can actually wire on that high leg and cause problems. You can put a lot of voltage, 277, onto a copy machine, or a coffee maker, or a vending machine real quick, and blow it up. So that's typical how that works.
That first cup of coffee, you'll get it really fast though, won't you?
Oh yeah.
On to other types of diagnostics here. One thing that we can get into is I'm going to take boiler diagnostics and make that its own individual video. And I think on the troubleshooting individual types of HVAC equipment, I think that's going to also be individual videos. We just can't in an event like this really get so detailed into every single one that we can lay it all out for you, but watch for additional videos coming up. There's again, knowing the sequence of operation and knowing that your power coming in is what it's supposed to be, and knowing what you're looking at probably, or could not, or possibly is not the way it's supposed to be. So you're going to have to, again, look at all the parameters. Is the wire size right? Is the breakers right? Verify everything before you go forward and say this is the problem, because you have to verify it. Even when you're doing that sequence of operation thing, say, okay, well, let's see, there's and again, it's all types of equipment, like Joe said, depending on what setting you're in. Maybe you're a maintenance tech at a facility. Maybe you are a facilities maintenance technician. You deal with lots of things. Maybe you just deal with machinery. Maybe you're just dealing with HVAC, or maybe your control systems, or who knows what. But you need to know that sequence of operation. But after a while, you're going to say, okay, bing, 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 and then there's that problem. Okay, well, now that you're pretty sure that the problem is there, but then you have to verify it. After you verify the problem, then you got to figure out why that happened, so that you can potentially keep it from happening again. It's always take that extra step. It is what caused it. A lot of times it's just going to be age, but in some cases you are going to be able to find additional problems and try to and get those rectified before you keep having the same problem over and over. Let's see here. What any other notes that you want to go over, Joe?
Yeah, I was just going through. I was looking at some of the live chat, and I really appreciate. Just really push how important it is to just keep communicate with us. The only way I know, and Guy knows how to guide the show in the right direction, is the notes. So I'm constantly keeping track of all the feed coming through. So we have quite a few people. They seem to really be enjoying the chat, and this is what the funny thing is. This is what Guy and I do off air. We'll do this for hours and just sit there and chat back and forth, and really have this bantering for like 2-3 hours until our wives get mad at us. But this is what we do. So we actually, to put a camera in front of us and have it on air is just another extension of what we actually do in real time. So all these conversations we're having is pretty much what we have normally. That being said, is having the chat from you guys, it really helps us to guide the conversation to something that you want to see. So I'm just looking at a few of them here. I got the Sanchez HVAC channel, it says great live chat. We had some technical issues earlier. I had a bunch of people saying they can't hear you, so they they got it under control. But it looks like we have just a great a couple things. One of the question was this is from Sanchez HVAC. Was the breaker that was tripping since the beginning? And it's question mark. I always wondered if that would work for a while. I'm taking that question as, you know, we had earlier about the overloading breaker. Yes, if you had a breaker system, not a fuse system, and let's say it was say a motor was loaded down, or a system, but let's say a motor was loaded, you could trip the breaker because the breaker takes the overload. Yes, you could reset it and reset that and cause it to get functionality to get you through a mess. After the second, by the second time, you should have a red flag coming up saying, you know, something's wrong here. By the third time, definitely don't keep resetting it. You're giving yourself problems, because what you're doing is you're hitting that motor over and over. So you're going to end up changing the motor, which simply could be a gearbox having problems. Now you're going to be changing a gearbox and a motor, or you could be having a system like that.
You know how I found that problem, Joe? It's I had to sit there and just monitor the whole thing. I had my amp probe, and I just kept checking everything as the system was running through. And when it wasn't until all 3 electric strip heats were on and the compressor was on that I noticed that we were at 70 amps. We reached the peak of the breaker that was in the panel there. But the weird thing is, on this particular call, is that the main panel, or the MDP, the main distribution panel there, was it had a 70 amp in it, and my disconnect had a 60 amp in it. But it wouldn't blow the 60 amp, but it would blow the 70 amp. So I referred this problem to the electricians, because I believe, first of all, I mean, they're going to have to change the breakers anyway because they're undersized. But there was a problem with that 60 amp breaker. In this particular situation, I could have had them just run another feed for, say, 35 amps and feed the unit, so that I had like one for the strip heat and I had one for the compressor, and I could have fed it with 2 different feeds. But they were going to have to change these out anyway. And I kind of took that question, Joe, as he was saying, if it trips, you know, how many times can a breaker trip before it starts to get weak? And I'm going to have to, and maybe you can tell us that, you know, if it trips once or twice, you're probably okay. But the more and more it trips, the weaker and weaker that breaker's going to get.
Yes, that's very true. Your breakers only have a certain lifespan. They're only designed to do certain things. I've seen them I've seen breakers used as light switch in many applications where people actually turn them off and on as a light switch. They're not light switches. You don't turn off your lights with a breaker. You don't turn off your heat. You don't turn off your HVAC. You don't turn off it's not a light switch. They're designed to do one thing, and that's to break a load or break a overcurrent. So that being said, you know, toggling back and forth off and on it will destroy them over time. Now, they might work for 100 cycles, but that's about, you know, they're going to start getting weaker and weaker. After they've been hit with a high current, they are slightly weaker than they were last time. So yes, it is possible to have a bad breaker. We've had situations in many past calls that we've had where just a good motor, brand new gearbox, brand new stuff, just kept on tripping. You know, finding out later that the breaker had been hit so many times by the old gearbox and the old motor that has weakened it to the point where it's below its threshold. When a motor starts up, it has something called Inrush, and that's basically the current it takes to get that from a 0 speed up to its rotating, its normal operation. In order to break that 0 speed, you need a lot of current, and we'll have to get into this a lot into motors video. But to really break that, it's called Inrush. A lot of current has to be used or utilized to get that thing moving and rotating. That being said, certain breakers, special breakers, have to be rated appropriately for that, And if it's so weak that it's actually below that threshold, you're going to have a tripping breaker. So you're going to be chasing your tail if you're not careful.
And one way to see what that inrush is on any piece of equipment would be to look at the rating plate. It's going to give you a minimum and a maximum ampacity circuit breaker rating on there, but it'll also give you an FLA, which is a full load amp. And in some cases on HVAC equipment, it'll also give you a locked rotor amp as well. So that would be that information that you'd be looking for there. But yeah, go ahead.
I'm just saying that a lot of the companies that manufacture motors and breakers, they have the worst case scenario in mind. So like you're saying, the full locked rotor is basically if you were to bolt that motor down, the shaft and the motor itself, and try to turn it on, how many amps is it going to pull? That's what that is, a locked rotor. It's not moving. The same thing with a breaker. They're going to have a bolt-on of current, which means that if you took a bar, which is a pretty dumb thing to do, took a bar thing and bolted all three phases and put the power to it, how much current would it take before it blew? That's a bolt-on.
Hey, that's how we made my e-stop.
That's right.
On the wind turbine, we shorted out all three phases, and it stopped her right in her tracks.
That's right. Yeah, if you take a motor, instead of providing power to it, and you give it mechanical power, in this case was a wind turbine, it's actually producing power. And one thing that motors don't like is to be all three phases bound together. When that happened in this situation here, we did that on purpose because it called something called eddy current. And once eddy current was created, it actually had magnetic braking or eddy current braking. You can refer to it as a regen or dynamic braking. Dynamic braking is probably more appropriate in this situation. But instead of sending the power off to a heater or a load, we actually put it a dead short. And the purpose of this was if the speed of the rotor of the turbine was to get too high, it would automatically switch over or manually switch over to a separate contact, which would actually short all three phases, and the thing would come to almost a dead stop, but a crawl, protecting itself from high winds.
Yeah, that's a whole nother video. We'll have to get into talking about solar and that sort of stuff to touch base on get a little deeper into that stuff. Yeah, so basically we're the electrical stuff here, I think, is the hardest for people to understand, and reading wiring schematics, which I think we ought to get into some wiring schematic videos in the future. I did a few in the past. I did a video on my phone where I had brought up like a water heater, and I went through the entire wiring schematic and kind of explained the operation and how that worked. And I think that helped quite a few people. And just taking these individual wiring diagrams and walking through them, basically talking out loud while I'm reading them, really seems to help people out. So if that's something that you're interested in seeing more of, again, leave those comments down below. And that's how we know what you guys are looking for. And again, there's no way I do want to say this. I do get a lot of comments every day. I get comments, and I get specific questions asked, and it is very hard, especially over this communication here, is to try to help somebody with very specific questions. Like, I have this wire and I did this thing and I connected it here, but it's not working. What do you think? And I don't know. I mean, I have to look at it really. I've asked for people to take pictures or a small video of whatever it is they're looking at and send it to me so that I can put my own eyes on it. But my goal is to get you guys to know how to trust your process. There's no way you're ever going to know everything there is to know out there. Experience will get you there a lot, but you need to know the process, and you need to trust your process to know how to get the problem resolved. Also, use your cell phone, use your smartphone. it is a resource that we didn't have 20 years ago. We didn't have that stuff to look up before. I use it almost every day. Maybe I pull up some data, or if I'm working on a piece of equipment and you look around, in the old days, there was always a manual there somewhere to look at. 9 times out of 10, you take the panel off of something, the wiring schematic is shot and you can't see it. So use your resources. And that's the other thing about troubleshooting and diagnosing stuff, is you're not going to have the information when you show up to the job site, but you need to know where to get it from if you can't get it out of yourself. Tech support numbers. Almost everything these days has some sort of tech support number. If it's a machine, and if it's a piece of equipment, HVAC or whatever it is, there's tech support out there somewhere. So utilize those resources and keep those close at hand, because those guys are there to help you with that piece of equipment. And the nice thing about tech support, factory tech support, is it's something that they probably have seen in the past, so they're going to be able to help to get you there a lot faster. One thought eluded me, Joe, so you go ahead and talk for a second, and I'm going to try to recall that thought.
All right. Well, actually, I have a comment here that it's a question for you, because I'm going to let you take this one because it's more your field. This is from the Sanchez HVAC again. It says, I have a question about troubleshooting building automation softwares like the Train Tracer. Is that something you need to go to their training course for? Can you elaborate on that?
Okay. Pretty much, yes. Anytime you're dealing with an EMS, an energy management system, they're all proprietary. And now if you're good at touching and feel, I call it touching and feeling. I mean, that's about the only way I can describe it, is, you get in there and start pushing buttons. And, but yeah, if you want a deep understanding of that system, you have to contact Train directly and get set up on some sort of information, schooling, things like that. All these manufacturers have their own systems out there. And the thing about an EMS, they're almost outdated as soon as they get installed, because it's like a cell phone. A couple of years down the road, the newest systems come out and the other stuff becomes obsolete. But contact Train. They should be able to help you.
That's a great point. Yeah, I mean, just even in my my industry of automation, I use the PLCs a lot for what I do for robotics and system controls. And Rockwell is mostly our primary manufacturer of our processors. But and the best way to understand their system completely is to have the factory trained training. That's always the best. A lot of times that's not available. A lot of times, a little extra homework at home, or just going through some notes or going through stuff. Hopefully through the course of these videos and the course of all the stuff that we're trying to put online, people are going to get a little stronger at troubleshooting and try to figure out, things that we've run into that won't trip you up. Things that we spent 6-8 hours on to try to find a problem. Maybe you can just quickly, within an hour, have it up and running and make you look like a hero. Which is the whole point behind this, is that the fact that we can help people. I said, we do this. This is us. This is what we talk about all the time. We banter back and forth. And Guy had the great idea to help others. If more people could watch this, and the fact that we can communicate with people, thousands of people at one time, and talk to them, and the fact that we can, have a conversation with a community of people that are like-minded. It's amazing. So anyways, the point was, the factory trained courses and this whole thing is, definitely do what you can. If you to you or affordable to you, then by all means. I know some of the courses that I have to take are thousands of dollars per course. But that's just a basic refreshers, or they have to give you, their spiel of how to do this, don't do this. It's sometimes it is typically the best way to do it, but it's not the only way. Just by getting in there and really, knowing your machine and playing with it and trial and error helps a lot as well.
Speaking of that, to expand on those, the factory training is the best training you're going to get on specific equipment. And for example, not only is it factory training, like for example, say Carrier on Carrier equipment, there are chillers, there's screw chillers, there's different control systems that they use. They have EMS systems, lock and var boilers. They have night boilers and regular, hydronic boilers, and then there's steam boilers, and then there's Train is very proprietary, and each one of these manufacturers is proprietary, and it is, none of them are the same. So you have to know a wide gamut of information to be able to walk through these. And in the old days there, and a lot of the equipment, you can't diagnose unless you got a book. You need to know exactly which pin has what voltage on it, because 2 volts DC here is going to be something different than 5 volts or 10 volts DC there. And then you're going to get, there's VAV boxes, and there's just so many different things that you're going to run across. That's what was always amazing to me in this industry. Not only do you have to know, it's not just heating and cooling, it's electrical, and it's AC volts and DC volts and single phase and 3-phase and 480 and the wild leg and knowing all your tools and how to use them. And it's not just your basic hand tools, man. You do HVAC, there's a tool for everything. And you need to know sheet metal, and you need to know gas and gas pressures and refrigerants. And do you actually know how many refrigerants there are out there? I don't know offhand, but there's a lot of them. And then you got to go to the state and get certified, and you got to deal with the EPA and make sure you're certified there. And then you have you have to understand building and construction. If you're doing new construction or retrofits, you can't just go cutting into a wall to put in a register or return air vent. You need to understand, is that a load bearing wall? Can I actually cut that wall? I mean, there's so many different things that you need to know. And on the electrical side of things, there's controls. There is so many controls. There's 15 amp switches, there's 20 amp switches, there's 2-pole switches, 3-pole switches, there's automated sensors, and all of these things have piles and piles of books that come with them too. So you're not going to have all this stuff upstairs. You just got to go out. You got to know where to get the information is the thing. You have to have a wide understanding of all this stuff and know where to go get the information. And today, in today's technology and these cell phones, use it a lot. That's all I can say there. I wanted to touch base real quick and also let you know, Joe talked about the classes and how much this stuff costs. They're very expensive. Now, if you're working for a company, I would highly suggest you go talk to your boss. You can, get some of these factory trainings, because it's only going to benefit them if you know what you're doing when you're out in the field. The other thing I want to let you know is that we are working on modules to put together courses ourselves, so that we can cover a lot of this information and get them in small, affordable chunks of information. And I'm talking, these are going to be high-end, very detailed learning modules that are going to be available in the coming, hopefully within the year, but they are going to be all put together and be available in the future here. So those will be available for you guys as well. But don't worry about, I know you might think, oh geez, they're going to start charging us for this information, but no, these live events and the videos that I put out, those are always going to be there. They're always going to come. And I want to do more. If anything, I want to get more of these videos out for you guys. I just have a great time doing it. I have fun, and I think Joe has a good time with it as well. Our schedules are hectic, I'm a first shift. Joe's a third shift. We both have families, and we just, everything coming together and coming and going, and especially around the holidays here, it's hard to get everything to line up perfectly sometimes. We've been trying to do them on Mondays, but we had some scheduling conflicts yesterday, so we did the live event today. So yeah, lots of good stuff to come. Joe was talking about the building or this community that we're in, the communication with everybody. I have the 2 websites getting built. I should have that proposal from the company here shortly to have that stuff put together. But we're putting together Facebook community as well. There's a bunch of links down below for the Facebook pages and Facebook group. So feel free to check those out. Joe is working as well as far as getting everything on his end of things put together. And Joe is going to expand on the electrical side of things. I know there was a lot of subscribers on my channel that originally started watching because I did a series on basic electrical stuff. And the idea behind those videos was to just get that basic information out there, because some people don't know anything about that receptacle on the wall or the light switch or how any of that works. They don't know the difference between a breaker and a fuse. So I just want to get some basic information out there so that the average homeowner would have an understanding of what's going on in their house. And if you don't know, I primarily based my channel around encompassing self-reliance, and this is a big part of it. And we're kind of bringing it all together here. And so I'm just rambling, Joe. What do you got to say to close this out here?
Yeah, I got a few things to add to what you said, and then I got some comments I want to read to you. So the first part, yes, these modules where we've been talking about, this is just going on what we've been kind of going over, but it's gonna be in detail. It's gonna be the fact that you can take these classes and courses and really have an understanding of what's going on, and it's gonna put it in a nice little clean package. The free content is gonna be for obviously general public because we want the information out there. The pay courses are going to be the fact that we can actually start, catching up on some of our equipment that we've been buying just to get to this point. So hopefully we can continue going farther and farther and have the point where we can have great content and, have a little, and none of this ever goes toward us. It's all goes back into the channel. But in order to have what we have now, we've had to come out of pocket. So anyways, that module is what's going to help with that part. So hopefully with everybody joining together will help us on that. But that is not the primary reason we're doing this. There's never was a financial jump. It's always been a community of knowledge. But yes, we're talking about I will be launching a channel myself very shortly. And it's going to be covering things in conjunction with Guy, but it's going to be covering things like, automation, electricity, that kind of stuff, which is going to working with his side as well. Also having things like Halloween props and servo motors and controllers and, that kind of stuff, things that are a little more on the fun side as well, as far as things you can do with electricity and things you can do with projects, that kind of stuff. So I'm working on that on the backfield, trying to get all this stuff done. But as of right now, I'm collaborating with encompassing self-reliance and trying to work together with that team and get all this together. So, but yes, I really appreciate everybody that's out there. I mean, I'm watching the comments come in. They're great. I'm watching the viewers and people that are online. And this is what we wanted. This is what we wanted, people to have a big conversation together and have this this community of knowledge. And hopefully we've thrown out the idea of having, a program or like you said, modules, like little classes that possibly we can maybe have certifications at one point someday, down the road, where you can actually take it to employer and say, look, I took these courses or something like that. We haven't really got to that point yet, but it's all down the road. It's all part of the big picture. A couple comments I really wanted to get to that it's kind of funny watching the comments. So we had our loyal commenter, the Sanchez HVAC, had one more question, and that was about the breaker that we're talking about. Could a bad breaker or a factory installed breaker be malfunctioning? from the get-go. And that is, yes, I've had them out of the box fail instantly. That's very, very common. I won't say common, but it's happens. They're parts like anything else. Another thing is we had another one was Christine was asking about a HVAC system she had, I guess it looks like from her home. And it's 12 years old. And the rep she had come out, or the HVAC guy, said it needs to be replaced at 12 years. And I'll let you elaborate on this. And what do you think about that? About age?
Well, the average lifespan of, and I'm just talking typicals here because I have absolutely no details, but a 12-year-old furnace still has life left in it. The average life of a furnace is about 18 to 20 years. That's, again, average. If it wasn't installed properly and airflow was an issue, where the furnace was over-temping, getting too hot, operating on high limit or something of the sort, that can tax the heat exchanger. The heat exchanger is pretty much the heart of the system, and heat exchangers can be replaced. Most manufacturers offer at least a 10-year, and some manufacturers offer a 20-year heat exchanger warranty. So for a technician to come in and tell you right off the bat that you need a new furnace, I'm guessing that you second guess that. Get a second opinion. And the bad thing about that is every second opinion you get is going to cost you money. But maybe if she could leave, the model number, the information, the brand, or even let me know what the problem is, maybe I can kind of point her in a direction there. But it's really hard without seeing it. What I would love to be able to do is to, be a virtual tech for everybody that's out there. I would love to be able to look at my camera or my video screen here and have somebody on the other side, and I'm watching them and looking around and say, move to the left and put your meter here and do this and do that. That would be awesome. Maybe, Joe, we can devise an app that will allow us to do that, so we can be in everybody's pocket all the time. That would be pretty fun. That'd be pretty awesome.
Absolutely. She had one more question. The second part of that question was, I thought about buying a unit online, I guess, and installing herself, or having someone install it that is not a professional. And then I had our good friend Sanchez HVAC commented that it needs to be. I'm assuming he has his own company. He said no, it's installed. Yes and no. Okay, so this is my side of it, and I'll let Guy elaborate on this, because again, HVAC is not my forte unless it's controls or electrical. So as far as buying online and do it yourself, I'm all for that. Always have been. As far as getting the gases and everything hooked up properly and legally, I would really highly recommend that a trained, licensed professional does that work for you. So yes, I'm always about do it yourself. I'm always about, that thing. And I've done quite a few projects myself, just because I can. But on the other side of that, you got to follow the rules and the laws of the state you're in. And, and these people are highly trained and know very well what they're doing. That's why they do charge so much, because of that knowledge. So I would recommend that, but that's my side. Go ahead.
Yeah. I agree with you, Joe. There's different aspects to look at on this. I don't recommend installing one of these yourself. I don't recommend having your brother-in-law install one of these yourself. There's too many variables that could potentially cause you harm or death. They're gas appliances, and they can produce carbon monoxide. There's laws put in place with the codes that help prevent things like this. So there's too many variables to say that the brother-in-law could get it installed for you, or even a handyman. Handyman might be pretty handy, but installing one of these is not something I recommend. There's gas pressures that have to be set, airflows that need to be just right. The venting's got to be A1. If you're to get right down to legalities of things, if you had a furnace installed and it actually caused your house to burn down and there was no record of a permit being pulled on that unit, the insurance company could deny any claims that you had on your policy, because you didn't have permits and have it inspected. So I would highly recommend against that. Now, if you buy a unit online, and that's a pretty valid question, I would say, yeah, go ahead and buy a system online. Don't buy a used one, but if you can get your hands on a brand new unit, by all means, you're going to save a ton of money. Most contractors are going to charge you a markup. They're buying wholesale and they're selling retail. That's obvious. It's not a hidden secret. It's how Walmart makes its money. You know what I mean? So if you can find a unit and have it delivered to your house and ready to go, and then you have to find a company willing to install it. So I would talk to companies, ask around, because a lot of them are just going to tell you no, that they don't want any part to do with that because they want to make their markup. They're going to tell you, I can't warranty it after I install it if they do it, but they can. They don't have to offer you a 1-year warranty. Most companies do offer 1-year warranty on equipment that they supply. Now, they're not going to warranty anything that they didn't supply, but like heat exchanger warranties and parts warranties and things like this, that is covered by the manufacturer. So with the model and serial number, depending on which equipment you get, model and serial number can be traced back to the manufacturer, and they know right where it is. Especially when you get your product, there's a registration card in there. You register it, so the factory knows right where that appliance is and who has it, and when it was installed and all that sort of thing. So yes to buying it online, no to having your brother-in-law install it or whoever. So I wanted to real quick go back to the bad parts out of the box question that was on the comments there. And I've had a lot of bad parts and control modules, and I don't think I've ever had a transformer bad, but a lot of electronics a lot of times can be bad. I've had motors bad even right out of the box. Yeah, that happens more times than you would like to think it does, but it does happen. So again, you have to don't trust anything. And going back one more step here and saying that, I think earlier, Joe, you said something about you installed a new motor, or the new motor was installed and it was still tripping a breaker. Well, if you don't have the experience, you would say, geez, that motor's bad right out of the box. And that could cost hundreds, if not thousands of dollars. But again, you don't trust anything. If it's tripping a breaker, you need to amp it. You need to check amp draws. And you might find that it's not pulling too many amps. It might, hopefully it runs for long enough that you can actually see that spike. But yeah, always verify everything and never trust anything.
Yeah, I've had a couple of situations where, and I'm going to start bringing this to a close. I know it's been going for a while, but yeah, I've had variable frequency drives right out of the box blow up my hand, and they were, and to the point I was actually questioning my wiring, and we were able to get a second one acquired quickly and popped it in with the same wiring, everything else, and it ran fine. So just internal stuff, the even expensive high-end equipment. I've had breakers, I've had relays and motor starters, and so they're manufactured like anything else. They're going to break, they're going to have flaws. A couple things I want to hit on. I've got a couple more last comments, and then I guess I'll let you do closing. So I have actually, these are just more of a comments than questions. Michael, it says, Basic 101, your show you had, is how I found you, Mr. Guy, and it helped him out a lot. and it says, bringing my HVAC, beginning my HVAC teacher, I'm sorry, didn't. So I guess he's saying that he didn't learn, he got more information out of you from your channel or that show, far as talking plain English than talking technical over people's head. And that's what we're trying to do. That's the point of this whole thing. And then it says that, guys like you, help with, training online and YouTube. And then also very nice comments from the Sanchez HVAC about supporting us as far as what we're doing here in the classes we're talking about doing. So, I mean, the community is out there, people out there, just like, Guy and I, we're just people. We're nobody special. We've learned from the basic, from the ground up. I have a passion for electricity and automation and that kind of stuff. And I've self-taught myself quite a bit. I've had a lot of people that were older than me that taught me a lot of stuff that, just kind of not talking and listening to them and let them talk, let them share their knowledge, and absorbing all that information has got me a long way. So I'm really hoping that this situation here, what we're doing here is the same thing. Is we're going to be talking and communicating, and hopefully to the point where you guys will just absorb all that and take it onto your careers, knowledge levels, or whatever you guys need, even if it's through school or anything else. I mean, just really to have that opportunity, just to learn and to communicate and talk together. That's the point of this whole thing. So,
hey, really, Joe, you said something that really resonates with me, that we need to get out with people here, is that you learned a lot by osmosis. And you didn't say osmosis, but that's what it is. It's just by being there and absorbing the information, watching and listening. If you get lucky enough to get paired with a journeyman or somebody that's been in the field a long time, your best bet is to just zip it and listen to what they have to say, because they've been around the block, and you're going to be able to take their information, and their information as old timers is going to get you. You will learn more in the field than you will ever learn sitting in a classroom. There's absolutely, hands down, you will get more practical application experience and information by wrenching on stuff yourself, right along with somebody that can show you the ropes, which is something I wanted to quickly touch base on. I've had a bunch of questions on how to get a job doing, HVAC or an electrician. And it is such a hard thing to touch base on, and how to do it, how to get a job without experience and how to get experience without a job. It's the age old question, and in some cases it's luck of the draw, it's persistence. It's by putting together a good resume. It's by having some certifications in your pocket. It's by having, say, this is what I've done, this is the information that I know. It's persistence. Some of it is who you know. Sometimes you can get in because you know somebody. I recommend that anybody look up if you want to be an electrician, you look up the electrical apprenticeship programs. If you want to be an HVAC or a pipe fitter or anything of that sort, I would have you go check out the plumbers and pipe fitters and HVAC union, and check on their apprenticeship programs. Right now is a great time to get into the field, because the baby boomers all are becoming of retirement age, and the workforce is going to be diminishing as they retire, and we need people to replenish the workforce as far as these skilled trades go. There's going to be a big void shortly, and so if you're getting into either electrical or plumbing or heating and cooling or any of these skilled trades, now is a great time to do it. When I was in high school, they actually taught it in high school, shop class, and I went to a VOTEC school in lieu of half of my school day. So there was a lot of these skilled trades being taught in school, but they're not anymore. So, and they probably are in certain areas, but my area, it's gone. So I don't know who's going to replace me when I retire. I don't want to work until I'm 80, but it looks like I may have to. This is what kind of brought me together to want to put together some courses and classes and just get the information out there and teach everybody as much as I can, as quick as I can. So, yeah, I don't have any more notes, Joe. This has been a great program. I really appreciate everybody coming and making, leaving comments down below. And Joe, I appreciate your time. I know you're a super busy guy, and this is great to be able to put this together and offer it out for people. If anybody else has any more comments or questions, by all means, go down below and check out those links. Click subscribe and go to go sign up for the Twitter, follow me on Twitter and Facebook pages. I have Encompassing HVAC, Encompassing Self-Reliance. Both of those are YouTube pages and websites. Websites are in the works. I also have Encompassing Self-Reliance Facebook group as well. These are all new communities, and you're more than welcome to come join and be a part of the community. So with that being said, anything last notes from you, Joe?
No, I'd like to just really thank everybody. I'm just really watching the comments and just really impressed to the people that are supporting this. It's really nice to see people that are trying to learn. You hear about all the time people just wanting a handout, and there's so many people out there that they want to work. They want to better their society. They want to better themselves. They want to better their families. And it's really nice to sit here and look at the comments and realize that people out there are still really interested in these skills and these things, and just have questions. I mean, do-it-yourself questions or how to get into a career or whatever. It's really nice to see all that stuff, and I really appreciate everybody's joining. And I encourage everybody to keep it coming, even after the show goes off. Just to really just keep them coming. Let us know what's going on, and then as we build this community, get it a little more stronger. Hopefully, we'll have more information, more chances for people to learn, more people to expand their knowledge, and hopefully, either help themselves or help others. So I really appreciate it. I just want to say thank you to everybody, and it's really been a pleasure to work with Mr. Guy here, and just to have a great time together. And this has just been a lot of fun.
Joe, I don't think I'm glad you said thank you, because I don't think I've said it enough. I do also appreciate everybody's interaction with what we're doing here. So stay tuned, and we will be doing another live event. We're trying to do one live event every week, at least for now. We do want to turn that into more, but as schedules allow and we start to get some traction, it'll be one for now. And I'm still doing about one video besides that a week, and I want to try to ramp that up a little bit. And then we're also working on podcast. And excuse me, real quick. Okay, sorry about that. We've been talking for an hour. My throat's getting a little dry. I'd never be a good public speaker, probably. I'd be drinking water the whole time. But yeah, anyway, so yeah, thanks a lot for hanging out, and I'm having a great time. And don't forget, if you know anybody else that would be interested in any of this information, share it on Facebook, share it on Twitter, share it with your friends. I back to that comment somebody had said there, Joe, that they learned more or learned quite a bit by watching the videos. And I've gotten a lot of comments like that. I've learned more in your 2.5-minute video than I have in the past 3 weeks with my instructor. And, I don't quite understand where the disconnect is there. I'm a common guy. I'm a common guy. I put my pants on just like you. And Joe, you're a common guy. And, it's probably teaching styles. Joe has a lot of experience with teaching, and I'm getting a lot of feedback on my teaching style. So I think together we're going to make a great team and get a lot of information out there for you. Bear with us. We're working on it, and we're getting it all to jive together pretty well. So With that being said, thanks a lot for watching. Leave your comments, click like, subscribe. We'll see you all in the next video.